Let's find an equation for the tangent line to the graph of g of x equals square root of 3x at x equals 12. So I'm going to write down the three ingredients I need to write an equation of a tangent line. I need x, I need y, and I need m. If I have these three, I'm going to use the point slope form to write an equation. Okay? They gave us x is 12, so that's good. We can easily find what y is by plugging in the given x value into the function. So y is g of 12. So plug in the 12 into the function they gave us. That's going to be, what's wrong with the square root? Square root of 3 times 12. Well, 3 times 12 is 36, and square root of 36 is 6. So it did some work to find the y value. Now we need to think about how to find that m, the slope. Slope, you can find it by plugging in that same x of 12, not into the g of x, but g prime of x. Okay? So that's going to take us some work. We will have to find the derivative function. Once we have it, we're going to plug in 12 into that function, and that's how we find the slope of this tangent line. So let's find this unknown slope now, okay? Right now, we will have to use the limit definition of derivative, the long method. So let's write that formula down. The derivative is limit as h approaches 0 of the difference quotient. The function name is g, so I'll go ahead and say g of x plus h minus g of x all over h. So let's do this. I'm going to find what g of x plus h is first. Simply plugging in x plus h into the function. So what's that going to be? Hold on. That is going to be square root of 3 times, see, this is what I'm doing right there, not x, but x plus h. I got that. Now the next thing, the formula says subtract, right? So right there, the subtraction sign. So I'll say minus, and they want us to subtract g of x from it. And g of x is just that. So I'll write down square root of 3x all over h. So my goal is to find this difference quotient. When I'm done simplifying this, I will plug in h equals 0. Okay, so let's just work with this for right now. Remember, I think in the previous example I showed you, whenever you have a form like this, you will multiply the top and bottom by the conjugate of this orange minus green. So what's that going to be? It's going to be exactly the same as this numerator. Look at what I'm doing here. I'm going to copy this. I'm literally copying this. But instead of the minus in the middle, put a plus there. Okay? If you're multiplying that to the top, you need to multiply the same thing to the bottom. So that's the work that you're going to set up. Now, this becomes a form of a minus b times a plus b. I'll kind of write it on top of this. You have a minus b times a plus b, don't we? And we know that simplifies to a squared minus b squared. So I'm going to use that pattern to do this. So here's a little note. Okay. What we have right here is a minus b times a plus b. And note that this turns into a squared minus b squared. That's what this fancy numerator is talking about right there. So now, look, a is the orange. Square root of 3 plus h, 3 times x plus h. So if you square that, you if you square that square root, things inside will just come straight out. Right? No more square root. Now, b is the second square root expression, square root of 3x. If you square that, what comes out? The 3x comes straight out. Now, I think I'm going to go ahead and put them together, but I noticed that a squared can be distributed. So let me write this as 3x plus 3h. There you go. Now let's write the big numerator. I don't think it has to be that big anymore. The numerator has to be a squared minus b squared. Okay, a squared is this, b squared is this. So let's subtract these two. I will say 3x plus 3h minus 3x. And in the denominator, there's nothing much we can do about the denominator. You write the h, and then you're multiplying this h by this big other denominator. So you just have to write it that way, okay? All right, we're almost done simplifying the difference quotient. Let me make this note a little bit smaller on the side. Okay, so you notice that we can now cancel out this 3x and the negative 3x, right? Those are now gone. Not only that, you notice that we have h. Well, the only thing left is 3h now, right? Let me maybe even erase this so you can see. You see that we have h on top and h in the bottom, right? So we can cross those out. Now they cancel out. So the simplified difference quotient is 3 over this mess. Now remember, when we are done simplifying, we're going to plug in h equals 0. Because that is what g prime of x is. That's what the derivative is. So now it's time for us to plug in h equals 0. Okay, so where is h? Let me find h. Right there. So that's going to turn into 0. So g prime of x is equal to 3 over square root of 3 times x plus 0 plus square root of 3x. Let's simplify that. 3 over square root of, now what's this going to be? That's 3, right? And that's just going to be x. So, you know, the first square root will only have 3x left inside. And I'm adding another 3x in the bottom. So if I add 3x and another 3x, well, square root of 3x and another square root of 3x, you agree we can write this as 2 square root of 3x, right? We have 2 of those. And that is what g prime of x is. Why did we do all this work? Well, because this is our slope maker. G prime gives us the slope of a tangent line. Remember the x value they gave us was 12, right? So what I'm going to do is I'm going to plug in 12 into this function. The slope of this tangent line is g prime of 12. So let us plug in 12 into this derivative function. That is 3 over 2 times square root of 3 times 12. All right, let's try to simplify this. That is 3 over 2 times square root of 36. Well, that's a perfect square. We can say that is 3 over 2 times 6, 3 over 12, and finally, woo, the slope of this tangent line is 1/4, 1 over 4. So we found the slope finally. Let me write this down in my treasure box because I've been collecting these. I've been collecting these for 3 ingredients. If I have these 3 numbers, I'm ready to write the equation of the tangent line. So I'm going to copy this We'll bring it down here, and I'll show you how we can finish this problem up. So once you have your x, y, and m, you will do the point slope form. Point slope form says an equation of a linear function can be written as y minus y1 equals m times x minus x1 if we have a point and a slope. Okay, we have a point. The point is 12, 6. So I know these letters says x and y, but these are actually our x1 value and y1 value. So take a look. I'm going to plug in this 12 into x1 right there. And I'm going to plug in 6 into this y1. And the last one, the one that we took that took a long time to figure out. This quarter is going to be your slope. So let's write the final answer. I have to say y minus what? 6. Right after the equal sign, we need quarter, open parenthesis, and we do x minus what number? 12. I am done. This is the equation of a tangent line in point slope form. If my math lab asks you to, or your homework or your exam, I don't think I will, but this is where I will be happy if you stop at, okay? But if you want to continue and write this in slope-intercept form, you will have to do maybe 2 more steps. Distribute this slope and get y minus 6 equals quarter x minus 12 times quarter. What is quarter of 12? That's 3. And then, lastly, add 6 to both sides. So, another correct answer will be y equals quarter x negative 3 plus 6. That's going to be positive 3. So, I'll circle this too. Both pink circled equations are correct. Both are fine. And I'm fine if you stop right there. But if you want to do 2 more steps, you can write this in the more friendly y equals mx plus b form.